Okay, so in the previous video we showed that there exists an element in G, the group, such that for all elements in G, G star E is equal to E star G is equal to G. And we also showed that there exists G inverse that for all G in G, there exists an inverse element in G, such that G star G star G inverse is equal to G inverse G equals the identity. Okay. So what we want to do is we want to kind of improve on that and then say that there exists only one, which is how you do that, and that's what we're going to try and prove today. So first of all, let's assume that there are two different identities. Let's say there's E1 and such that this is true, and then there's also E2. Well then, if this is the case, then we have that E1 star G is equal to E2 star G, and we can multiply by G inverse on both sides. E1 star G is equal to G1 star inverse, and then G star G inverse. And this causes the G's to be cancelled out. This becomes an identity, this becomes an identity. It doesn't quite matter what identity it is, because we know identities keep the other one the same. So we get this E1 is equal to E2. Notice it doesn't matter whether these two are the same or different. Okay, and then we have E1 equals E2. And so if we have two identities that are equal, so that implies there's only one. So we can say this is true. There exists only one element such that this holds. Okay, so what about inverses? Can we show this unique inverses? Let's see. Suppose G star G inverse. This is G1. Notice that you could easily do the proof the other way around. Swap these two around and these two around, and the proof will work basically the same. So in this case, I've done the other way around. So suppose there's G2 inverse, and we want to show this equals the identity, and we want to show that these two are the same. So we know these identities are the same, although it doesn't particularly matter at the moment. So we can multiply both sides here and here by G inverse. And I'm going to skip a step and just say that they cancel now. And over here we multiply by G inverse. So, in fact, no. So in this case, we don't need to multiply by G inverse in two places. We only care about one place. So, just 1 sec. Let me just explain that one more time. In fact, let me explain it correctly, let's say. So what we're going to do is we're going to take this inverse and multiply it over here. So what we're going to do is do G2 inverse star G star G1 inverse equals G2 inverse star E. And since we know the right and left inverse is the same, this becomes identity, and we have that E star G inverse is equal to G2 inverse star E. So, and when you just keep the thing the same, so the two inverses are the same, and so we have that there is only one inverse. Okay, so that's the end of this video. So what we've shown here is that there is only one inverse, and there's only one identity. There's only one identity element, and for each element G in X, there's only one inverse.